Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the topic which I'm going to discuss is about Peltier effect. So talking about the process of Peltier's effect, here the electric current between two dissimilar materials will produce either heating or cooling effect. That is, the transfer of heat occurs from one junction to another. So the current flows from higher potential to lower potential. So when the two dissimilar metals are connected together at the junction, the heat would be either absorbed or released. So this is the basic principle behind Peltier's effect. So let us discuss the history of Peltier's effect. So a French watchmaker and a part-time physicist, Mr. Jean-Charles-Athanase Peltier, he found that an electric current would produce heating or cooling at the junction of two dissimilar metals. And in the year 1838, the lens showed that depending on the direction of this current flow, heat could be either removed from a junction to freeze water into ice, or by reversing the current, the heat can be generated to melt ice. So what here the lens is trying to tell is, based on the direction of the current flow, the heat can be either removed from the junction or uh, it could be generated. That is, removing heat from the junction is like freezing the water into ice. Or by reversing the current flow, the heat can be generated in order to melt the ice. So, to be more clear about Peltier's effect, we can define the Peltier's effect as the presence of heating or cooling at an electrified junction of two different conductors. And it is the temperature difference which is created by applying voltage between two electrodes, which is connected to a sample of semiconductor material. So we can also define this as the temperature difference between the two conductors is created by applying a voltage between two electrodes. So we can call electrodes as a conductor which the electricity enters or leaves an object. It is called as electrode. And the semiconductors, as we know, it is a solid substance that has conductivity which is between the insulator and the metals. That is, it partially conducts electricity. That is called semiconductor materials. It is the reason here is due to the addition of impurities because of the temperature effects. So this is called Peltier effect. So the Peltier effect process can be clearly explained from this picture. So we could see two dissimilar metals are taken here. So one is of where the N type, where more number of electrons are present. P type, more number of the majority charge carriers or holes here. And we could see that the current flow here, it is from the higher potential to lower potential. So this is the cooled side. We can see that the heat is dissipated in this direction. So this is the process of Peltier's effect. So the equation behind this Peltier effect is that, so the Peltier heat is generated at the junction per unit time. So if we consider the two conductors A and B, so which is dissimilar metals, so the heat may be either generated or removed at the junction. So the Peltier heat generated is given by this expression, that is Q is equal to pi A minus pi. So here into I, that is pi A and pi B are the Peltier coefficient of the conductor A and B, and here I is the electric current which is flowing from the junction A, the metal conductors from A to B. So talking in depth about the Peltier effect. So we are considering two dissimilar metals. So one, let us take it as copper, and the other one to be the iron. So this is acting as a thermocouple which is having both the junction at same temperature. So if the current is passed through this thermocouple, what happens is, first the heat is evolved at the junction A and it is absorbed at the junction B. So which means junction A is heated and the junction B is cooled. Similarly, At junction B, the current flows from copper to iron. So that is from lower potential to higher potential. Here, the energy is absorbed from the junction and it is cooled. Whereas at junction A, the current flows from iron to copper, that is higher potential to lower potential. Here, the energy is given out at this junction. So here, the junction A becomes hot, whereas in the previous case, junction B becomes hot. So we can also make this Peltier effect reversible. If the direction of current through the thermocouple is reversed, the heat evolved and absorbed at the junction can also be reversed. So this is what is the Peltier effect process. We can reverse the direction of the current so that the heat can be evolved and absorbed at the junction can also be reversed. So the applications of the Peltier effect is very commonly known thing is our refrigerator. So this effect is used in designing a refrigerator which is having no circulating fluid or moving parts. So these are used in applications where the disadvantage of low efficiency is outweighed. So that is, this might not be much efficient. So, but though we can use this Peltier effect to create a refrigerator which is very compact and there is no circulating fluid. In such cases, we can use this. And also the dehumidifiers. So the cooling effect of this type of Peltier pumps can be used to extract water from the air dehumidifiers. So this application we can use up to the temperature up to 20 degrees Celsius below the ambient temperature. And in satellite applications, this effect is used to prevent any direct effect of direct sunlight on one side of a craft by dissipating the heat over the cold shaded side. Hence, Peltier effect is used in satellite application as well. So today's assessment, how Peltier effect is used in fiber optic applications. So we know that in the wavelength is dependent on temperature. It is highly dependent on temperature. So this Peltier coolers are used with the thermistor in a feedback loop to maintain the constant temperature. So it will stabilize the wavelength of the device. So hence this Peltier effect is used in fiber optic applications. Thank you.